How do we find domain and range from a graph? Today we're going to learn how to do that, and we're also going to focus on writing all of these in algebraic and interval notation. So what I'd like you to do is actually to write this table down. I realize that it's a lot to write, but it's really going to help us throughout these notes. So go ahead and take a moment. As you're writing all of this down, you might notice a couple of things. First, this R, that's just the computer's version of this R, which is all real numbers. And secondly, if you look right here, you see this U, and a U is a union. And we'll talk more about that in a little bit. It's whenever you have a jump from one point to another. All right, so domain and range. First of all, what's the domain? The domain is the complete set of possible values of the independent variable. And for most of the time for us, that's going to be our x values because x is the independent. And it's the domain we read from left to right. Similarly, the range is the complete set of possible values in the dependent variable. So that, for us, is going to be the y values. We read them from negative to positive, so these are read from bottom to top. Okay. And let's dive right in and see if we can do this with a graph. All right, so let's find the domain and range of this function f of x. So here's the function f of x. The domain are all of the x values that are possible. Okay, and we read that from left to right. Like, you see over here at 6, f of x isn't defined at 6. So here's what I'm going to do. I'm going to highlight the x-axis wherever the function is defined. So I'm going to go to the x-axis, and here at -7, from -7 all the way to 1. So if you go to any of these x values, you're going to find a y. All right, so now that we know where our domain is, let's try to write these in algebraic and interval notation. All right, so you see how the x is trapped here between 2 points? Well, over here on our graphs, whenever we're trapped in between 2 points that are both included, because these are all solid dots, we write that x is between, so -7 is less than or equal to x, less than or equal to 1, right? I mean, this should make sense here. Like -2 is in our domain. -2 is greater than or equal to -7, and -2 is less than or equal to 1. So we know that we wrote it right. In interval notation, I just go along the same path here. We notice that these are 2 brackets. Brackets mean that things are included. So from left to right, it goes from -7 to 1. The range, we're going to do from bottom to top, we'll just go along the y-axis wherever the range is included. So here we have from right here all the way up to here. So there's never a break in the range, but the range goes from -5 to 5. So in inequality notation, that'd be -5 is less than or equal to all the y values for the range, less than or equal to 5. And then in interval notation, that's just -5 to 5, both in brackets. All right, so let's do the domain and range of this function here. I'll start with domain. Remember that we'll just go along the x-axis from where it starts on the left to where it ends on the right. All right, so this goes from -6 to 4. And if we notice, whenever you plug in a -6, you get a non-included point, right? So instead of -6 is less than or equal to x, we'll say -6 is less than x, less than or equal to 4. Whenever we have a point that's not included, instead of a bracket, we put a parentheses. So this interval is from -6 to 4, and the 4 is still included. Okay, now let's look at the range. I'm going to go along the y-axis from the lowest point to the highest point. There's never a break in between there, so my lowest point is -7. It's included. So negative 7 is less than or equal to y. And the highest point is 3, which is not included. So in interval notation, this negative 7 gets a bracket, the 3 gets a parentheses. Okay, here we have kind of a trickier problem because for the first time we see we do not have an ending point. We have this arrow. And whenever you have this arrow, you can assume that that forever goes down and to the left. So whenever I'm marking my domain, I go, okay, well, where does the domain stop on the left? Well, it doesn't. So it continues going that way, and then it'll go all the way to 3. Whenever we have this, just like a number line, right, because it's pretty much what we're graphing, all of these x values are less than 3. And notice I put less than instead of less than or equal to because this is not included. So in interval notation, we say, okay, it's going to keep going left and left and left forever. So where does it start in the left? It starts at negative infinity. And since we can't ever get to negative infinity, this is not included. It's a parentheses. And it stopped at 3. Now the range here is a little bit tougher because it's kind of tricky. You want to say that the range starts here, right? Right here at negative 3. But if you remember, this arrow is going to always go down. So it's just going to keep going down and down and down forever, right? Not at that same slope or anything. So the range actually starts way down in negative infinity as well and goes up to 7. So all of the y values are less than or equal to 7. Or in interval notation, this goes from negative infinity to 7 included. In this next example, we have this function here, but it has a break. It has a hole in the middle. So let's see how we would do this. The domain first here. So we can see that it goes from negative 5 to 3. But then right here, we have a hole at 0. Right? So there's a little thing right there too. Okay, so that should be open. I can't erase the pin. All right. So I'm going to do this in interval notation first, just because it'll help us write it in inequality. In interval notation, from left to right, it starts at negative 3, right? It's not included. And it goes to 0, where now there's a hole. So 0 cannot be included. And then we say, okay, it starts again on the other side of 0. And what does that mean, other side of 0? Whenever we get to 0, we're approaching it from the left. Then we jump over to right into the very smallest positive number and go to 3. So, and then this goes to 3, which was included. So whenever you have a union, this U, that's an OR in algebraic notation. So we can say, okay, negative 3 is less than x less than 0, or 0 is less than x less than or equal to 3. All right, the range, we're going to do the same way as we've been doing. We're going to go from bottom to top, going along the y-axis. Even though this point stops here, the range continued over here all the way up to 1. So the lowest y value was negative 4, and it was not included. So negative 4 is less than y. And then the top y point is 1, which is also not included. And there was no jump in between, just because for every single one of these y values, it has a corresponding point, right? So in interval notation, we should know now this is negative 4 to 1, neither of them included. All right, our last example. Here, whenever you're looking at your domain, we can see it goes all the way left and then comes to negative 3. Then it jumps and starts again here at positive 3 and goes on forever. So my domain here would be all of the x's that are less than negative 3, right? Not less than or equal to, because it's a whole. Or all of the x's that are greater than or equal to positive 3. So our interval notation or algebraic notation would be from negative infinity to negative 3, not included, and then it jumps, so we union included 3 to infinity. Now the range, so we can see that this side's going to go down forever. So the range starts here at negative infinity, and here it went up to here. And then if we pay attention to this side now, it started at negative 4 and then continued on forever. So there's never a point where the range isn't included. So in algebraic notation, we just say, okay, the range is all real numbers. And in interval notation, we say that's from negative infinity to infinity. All right, and that's our intro into domain and range.